things, and we will decide only to consider certain cases which are the ones that are happening more often. We don't need any software at the end host. This is an advantage because you need to keep it updated, and I guess the system administrator know how this is painful, how much this is painful. So you just do it on the fly. Whatever you need for the analysis, most of it is deployed on the fly, real time. You can have the single point has the malware analysis engine. That's the only one where you have to run the updates, but it's one point. We offload the heavy computations because when I mentioned before that this solution that basically which runs the analysis locally, they will basically take a lot of CPU time. Yes, we can offload on GPUs now. Still, your host is basically used as a dynamic malware analysis tool. So you might don't want this, right? So we offload all the computation somewhere else. And as we show in the demo, you can, if you're really paranoid, you can even press the red button and basically kill the malware right away, or suspend it, or whatever. This depends on the OS because Windows 7 64 bits has some differences with Windows 7 32, for instance. You cannot do the same thing. Nice that Microsoft implemented these functionalities, but it's possible. So we know that you can get around these analyses. It's clear. But if they decide, for instance, it's very back, so let's not jump to that slide. But if they would like to implement cryptography, if they would like to implement steganography, if they would like to implement hashing, keying, or whatever, this will just make the spreading of the infection much slower. Because then you need the real infrastructure behind to manage the keys or manage the hash. They will have to reveal themselves because there must be a single point that is always active that the malware can use as an oracle. Is this component good? Can I use it? Right? So in that moment, either they reveal themselves or you will find out what is the key or the hash or whatever. We are planning to publicly release the code of the red pill. So this is the URL. I know that in the presentation that the Blackhat has put on the CD, there is not this information, but we will update it. We will send a new presentation to the Blackhat staff so that they can put it online. So you can play with it at your own risk. And we're done. So now we can take questions. Sorry? Yeah.
Thank you. Question. So this will work if the malware goes out and grabs more stuff. It doesn't work in cases where malware already has everything in the background.
So the question was if this approach works only if the malware is downloading some extra components, or if it's going to work also if the malware is basically a monolithic executable. Well, in principle, no, it cannot work if the malware is not pulling down extra components, because the idea is we stop something that we inject into the malware. So we need really this phase in which we get into. That's why also the presentation is called Goodware drugs, because it's like giving it a medicine. You need this phase. So the question is how we detect the failed download attempts. So far it's a very naive approach. I would say that that's the weakest point because it's anomaly based. And so we just basically, there are some algorithms that, so in this case is the threshold walking algorithm that we adapt a little bit. And you basically have a rate of successful and failed attempts for that particular host or for that particular network that you can set. And then you basically can set a threshold and say, if it fails more than this number, provided that they have seen this amount of failed downloads, then you are gonna basically shift into operational mode and you will ship the red pill. So that's the weakest point right now, because it's not a silver bullet. We know that. So the worst case is the malware gets in, but it would have gotten in anyway because your antivirus has failed, otherwise the antivirus would have stopped it. And yeah, so sorry guys, but we couldn't make it. There is that.
I'm curious, so it relies on failed downloads to detect this behavior. Have you thought of maybe intentionally failing potentially suspicious looking downloads and then seeing if it retries that download again like a legitimate application would, or if it tries a different site then immediately?
So with the dataset B, we have tried to basically fake the downloads. So that's why 10 samples have been flagged as malicious. I would say that it depends on the working mode, because as I said, if you are paranoid, you will send right away the red pill, right? Whatever. Oh, there is a failed download. Yeah, here is the red pill. If you have this transparent mode, you basically wait for the file to be pulled down, so to actually find this file, so it would take another 10 attempts, but you know that then you're going to glue the red pill to it, and you will run the analysis. So yes, these are all weak points, and that's why I'm saying this is kind of proof of concept, and definitely you can do better. We just need some time, because this idea came out of the blue in March. So we want to make it work better, definitely. There was another question? Yes?
Yeah, one thing I'm not clear, you're saying that the failed download detection is the weak point.
Yeah.
On one hand. On the other hand, the numbers you showed here show that most of these failed downloads were eventually detected as real malware. So it does seem to give a pretty good match.
Yeah, but it's anyway a controlled setup. So because I come from the anomaly-based detection world, I can assure you it's the weakest point. So I would not trust it. It's the only so far it's the only thing we have found out that you can do, because apart from installing something on the machine. So provided that you don't want to install anything on the end host because you don't want to maintain it, you don't want to update it, and because you just don't want that shit on your machine, that seems to be the only way. So we can either refine it. The approach works, as I said in one of the very first slides, the approach works because there is this combination of two things. The idea came out because we were working on a honeypot that is not a real honeypot, that is monitoring everything, not waiting for something, and use again a kind of double approach, where you use the failed download as a kind of first line alert, and then you have something more on the honeypot that will tell you this is something really going wrong. So here is the same thing. You have a first line of alerting, which is the failed download rate, and then you have something else that will confirm or not your suspiciousness. So I would say that if you just take one of the two, that it doesn't work, because otherwise, if you take the flow-based, that's the technical name for that thing, flow-based analysis, they would already have solved it 10 years ago. Arbor is selling this solution for already 10 years, and I think we still have malware out there, right? So it doesn't work. The approach has to be smarter. I don't know if this is smart enough, but it's an initial step.
And then I was also just wondering about performance, like how much latency does it add, like how much computational power do you need, say, for supporting 1,000 hosts, or do you have any idea of those numbers?
Okay, so no, we have not definitely tested with 1,000 hosts. Sorry, yes. So the question is if we have any statistics about the workload that is required by this approach to work properly. So no, we don't have numbers with many hosts. I think that the latency when you are on the host to dump the information is basically not zero, but close to it, right? Right, Chris? It's just you dump information from the executable, and that's kind of straightforward. We have also some encryption because we don't want sensitive information to go over the network like this. So maybe that's the one that requires more computation. But because the actual analysis does not take place on the monitored host, but somewhere else, the only problem could be that if you really want to be paranoid, it's going to cost you a lot of time because you have to run first the malware, and then decide if the heuristic failed, because they failed, they are called heuristic for something, because you hope it's going to fit. But if it doesn't fit, then you have to go for the further analysis. And the further analysis is expensive in terms of times, because you have to wait for the malware to show up as malware or to be confirmed it's clean. The only good thing is that you can, the same way as like cloud antivirus, you can maybe have 3 or 4 different engines that you use at the same time, because you have the copy here in your hand of the original spore, so they're supposed to be malware, and you just send it out, and the first one who says something, okay, you take it for granted. It's malware, okay, I will switch it off. Yet, let's say that even if you are not paranoid and you cannot run the risk of switching off the malware right away on the host, you can still have the information that something went really wrong. So you might allow the execution of the end host to continue. You have the copy, you will run some extra analysis, it will take you 1 day, and after 1 day you know that the host is compromised. For some use cases, this is enough, because they want to know that the machine has been compromised as soon as possible. They don't care if some information, of course you want the information to stay inside your network, but they will not die for this, right? So it's all about your business case, I would say. Any other? Yeah.
Have you, in your research, seen any malware tunneling its communication over DNS requests?
Okay, so the question is if we have seen malware tunneling, so basically using side channels to communicate outside the world with something that we cannot control. As you, I think we forgot to say this, but so far we are monitoring the HTTP traffic, right? So in theory, this approach can work for any protocol. You just have to decide that you are gonna monitor a certain port. Yes, not in this project, but yes, we have seen. Yeah, in general, yes, we have seen there is some malware that is tailored, really tailored. I mean, we are talking about government agencies. They receive some tailored malware for a certain user, and that malware is going to use some side channels to cover channels to communicate with the mother. So yes, they do exist, but so far we monitor HTTP. In theory, it's possible to do whatever you want. So actually, I think on DNS it would work even better, because the DNS requests are so simple to, let's say, validate. So if all of a sudden you see something that you cannot validate, you are kind of sure that something weird is going on. But unfortunately, I would say if it's not DNS, they will use something else. So, I mean, the range of possibility is quite wide. Yes? Sorry, didn't get the question.